Now in part 3 of this video, we're going to do some mixed application problems. So in number 1, I'm asked to find the length of AC. Well, A to C is that altitude right there. So let's see what we have. We have 60 degrees here and here, which means this angle is 60 degrees. If this is 8 and this is 8, that means that this blue segment I'm after is the perpendicular bisector of that equilateral triangle. So that means this angle is 30 and this is 4. So if I look at just one of my end side triangles, I have a 30, 60, 90 triangle where I do happen to know 2 of the sides. Now I could use the Pythagorean theorem with 8 as my hypotenuse, or, and this segment here, give it a different name, we'll call it W, as one of my missing legs, or I could apply my 30, 60, 90 rule, and this W is the long leg, and I happen to know my short leg and my hypotenuse, and we know that 2 times the, wrong formula. We know that the short leg times the square root of 3 is our long leg, and so 4 square roots of 3 is this side W. Now you could have done the Pythagorean theorem and said 8 squared is equal to 4 squared plus W squared. 64 is equal to 16 plus W squared. Subtract 16 from both sides. W squared is 48. Take the square root. 48 has a perfect square of 16 times 3, and so W is 4 square roots of 3. And you end up in the same place, but with a lot less work. If I look at the next example, a 6-meter long ladder leans against a building. If the ladder makes an angle of 60 degrees with the ground, how far up the wall does the ladder reach? How far from the wall is the base of the ladder? Round your answers. Now when we're talking about ladders and length, it doesn't make sense to use radicals, but they are a good place to start. So here's my building, here's my ladder, my ground. We assume our buildings are standing straight up and down. So it's a 6-meter long ladder, so I know that that is 6. If the ladder makes an angle of 60 with the ground, how far up the ladder does it reach? Or how far up the wall? And then how far is it from the base? So really, I have a 30, 60, 90 triangle formed right here where I know the hypotenuse. And so I need to find the long leg and I need to find the short leg. So the hypotenuse is equal to 2 times the short leg. So 6 equals 2s. So my short leg is 3 meters. And my short leg times the square root of 3 is my long leg. So 3 square roots of 3 is my long leg. But again, we don't measure in square roots of 3. So if you go to your calculator and take 3 times the square root of 3, my long leg is approximately 5.2 meters. In the next example, a baseball diamond is a square with sides of 90 feet long. To the nearest foot, what is the length of a throw from home to second base? Well, clearly that is the hypotenuse of what becomes a 45, 45, 90. And so we know that the hypotenuse is the leg times the square root of 2. Our leg is 90, so our hypotenuse is 90 square roots of 2. And if we go to our calculator, because we don't measure in square roots of 2 units, we have approximately 127.3 feet to make that throw. Now if we look at B, what is the length of a throw from the shortstop position? We'll make a new picture. The shortstop plays about right there. To first base, if the shortstop is midway between second and third base. So remember, this whole thing was 90. If that shortstop is exactly halfway, this is 45 feet, and this is a right angle, and this is 90. So again, we could use the Pythagorean theorem, or we can look and see, do we have one of our special triangles? The only angle we know for sure is this 90. We can't assume, nor do we know, those two angles. So we go ahead and use our Pythagorean theorem that c squared is equal to 45 squared plus 90 squared. C squared is 2025 plus 8100. C squared is 10,125. And again, since we're talking about a real length, we go to our calculator, and C is approximately 100.6 feet. So sometimes you're going to use your new special right triangle rules, and sometimes it's okay to go back to the old familiar rules of the Pythagorean theorem. That is the end of this lesson. Good luck with your homework.